Hi everyone, in this video we are going to complete a review for Unit 3, our unit on three-dimensional geometry. So first up is volume. Remember, volume can only be used with three-dimensional figures because volume is the capacity of an object. It's how much space it occupies. It is that measurement of the inside of a three-dimensional figure. What can be filled? What space can be occupied? All right, let's start off with volume of a cube. If you notice up in the upper right-hand corner, we have our formula for volume of a cube. Your volume is equal to length times width times height. Let's check out our problem here. A cube has a side length of 6 feet. Find the volume. Oh, I'm only given one measurement, but I need length, width, and height. So how is this going to work? Well, if we take the knowledge that a cube is a three-dimensional square, that means that all of the sides are the same length. So that is the definition of a square. That is the definition of the three-dimensional version, cube. And if we're finding volume, that means it's a cube. So every side length is going to be the same. So that means our length, our width, and our height are all going to be 6 feet. So we can use our formula to substitute, to plug those in. So 6 is our length. That's going to be times our width of 6, and then times our height of 6. Now that everything is substituted, everything is plugged in, we can use our order of operations to find our volume. And in this case, there's only one operation. It is all multiplication. So we need to multiply 6 times 6 times 6, which would be 216. And then we can't forget our label. Our measurement was in feet. And because we are dealing with volume, that is a three-dimensional figure, we are multiplying 3 different side lengths. Therefore, it is feet cubed, so feet to the 3rd power. All right, next up is volume of a rectangular prism. Here is the awesome thing. When it comes to volume, our formula is the same, which is nice. We can learn one formula and it applies to 2 different shapes, cubes and rectangular prisms. Our first step is always to identify our information. I notice that we have a length of 6 feet, a width of 4 feet, and then a height of 1 foot. It's identified, so let's substitute that into our formula. Volume is equal to a length of 6 times a width of 4 times a height of 1. Now let's follow order of operations. Multiply 6 times 4 times 1 gives us a volume of 24. And once again, our measurement is in feet. So the volume is 24 feet cubed, or sometimes you might hear that 24 cubic feet. All right, the last shape that we are working with for volume this year is a triangular prism, so a three-dimensional triangle. This formula is similar, but just a wee bit different, because when we are dealing with triangles, or in this case, a triangular prism, it is half a rectangular prism. Because if you take 2 triangular prisms and you put them together, so one right side up, one upside down, they will form a rectangular prism. That's why our formula is 1/2 length times width times height. All right, different formula because it's a different shape, but our process is the same. We want to identify our information. We have a length of 6 feet, a width of 4, and a height of 6 feet. So we're going to substitute these into our formula. Volume is equal to 1/2 times our length of 6, our width of 4, and our height of 6. There are two different ways that most students deal with that fraction of a 1/2, and I'll go ahead and show you both ways. One way is we can convert that 1/2 to a decimal because that's a little bit easier to type into our calculator. So 1/2 as a decimal would be 0.5, and then we would multiply that by 6 times 4 and by 6. If we go that route, our answer is a volume of 72 feet cubed. Another method is when you multiply something by a half, you are cutting it in half. Another way to look at that is you are dividing by 2. So some students may like to look at the formula this way, where you are multiplying length times width times height, and then when you're all done, you will divide it by 2. You'll cut it in half. So if we do that, 6 times 4 times 6 gives us 144. When that's divided by 2, we have a volume of 72. So it is equal. Whichever method you use is okay. Just use what works best for you. All right, our next topic is surface area. So volume is the measurement of the inside of a three-dimensional shape. Surface area is the total area of the outside of the shape, the total outside surface area. So here we have two different diagrams. These are the common two that we've been focusing on, is cube and rectangular prism. And we can understand surface area a little bit better by using nets. A net is what is pictured here, what I've just drawn an arrow towards, and that is the unfolded version. So if you both of these look like boxes. If you take a box and you unfold it, that is the net, and then you fold it up and it creates that three-dimensional figure. So area, because you've worked with area before in 5th and 6th grade, area is the measurement inside a two-dimensional shape. So if we want surface area, that is going to be the area of all of our faces, is what these are called. So all of these squares combined together will give us the total surface area. So the area for the entire outside of a three-dimensional shape. And then same here for a rectangular prism. Just a rectangular prism's a little bit differently because we have 3 different side lengths. Therefore, we have 3 different sized rectangles or 3 different sized faces that will come together to form that three-dimensional rectangular prism. All right, enough talk about how it works. Let's get to it and go to the next slide. First up, we have surface area of a cube. So right here in orange, this is our formula for surface area of a cube. We need to do SA, which stands for surface area, is equal to 6 times A. And that lowercase a stands for, that lowercase a stands for the area of a square. So the area of one of our faces. That's what we need to find first. It's kind of like a puzzle. We need to get all the little pieces that are going to fit into this larger surface area formula, then we can apply it. So I notice here I have a cube, and right here we have one face, and that face happens to be a square. To find the area of a square, we take length times width. Well, we have a length of 4 and a width of 4. So area is equal to 4 times 4, which would be 16. Well, that's great, but that's not our final answer because that's just one piece. That is the area of one side of our square, of one face. If we want the surface area, we need to use this formula. Surface area is equal to 6 times the area of one side. The reason we multiply by 6 is because there are 6 total sides, and since it's a cube, they are all equal. They are all the same. Surface area is equal to 6 times 16, because that's the area of one side, the area of one face. And 6 times 16 gives us a total surface area of 96. In this case, our unit of measurement is meters, and because we're dealing with area, we are only multiplying 2 dimensions, because it is the outside. It would simply be meters squared. All right, let's do surface area of a rectangular prism. This one does have a different formula because unlike a cube, when we have a rectangular prism, all of our side lengths are different. We have, as we can see here, a length of 9 feet, a height of 2 feet, and a width of 3 feet. But that's okay, because you're used to finding that information. You just did that with volume. The only difference is we have a different formula. It's a little bit longer, so make sure you have that written down, but we are just going to follow it exactly. Okay? So surface area, that's the SA, is equal to 2, and then in parentheses, we're first off going to take our length times our width. So we have a length of 9 and a width of 3. That's going to give us the area of one side. Then that is added to our second one here, length times height. Well, we have a length of 9 feet times a height of 2 feet. That gives us another side. And then last but not least, we are going to do width times height. Our width is 3 and our height is 2. Now we got a lot of numbers here, but that's okay. We can use order of operations to help us out. Remember, order of operations, we often use that mnemonic, please excuse my dear Aunt Sally, PEMDAS, and that tells us we always need to deal with parentheses. So parentheses as a grouping symbol first, and we definitely have that right here. So see my laser pointer right here, the big set of parentheses, we want to work inside of there. So once I look inside of those grouping symbols, I notice that I have multiplication and addition. PEMDAS, order of operations, tells us to deal with any multiplication first. So first we have 9 times 3, which is 27. Oops, that's a little sloppy. And then 9 times 2, which is 18. And then 3 times 2, which is 6. All right, let's keep following that order of operations. We still got to get that grouping symbol simplified. So next up is going to be to add everything inside those parentheses. So 27 plus 18 plus 6 is 51. And last but not least, we're going to multiply by 2. 1, the formula tells us 2, but the reason for that is because there are 2 of every different size of the side. So there's 2 end pieces, 2 sides, and then a top and a bottom. So 51 times 2 gives us 102 as our total surface area. And because it's area, it is feet squared. All right, let's try a problem where we combine the two together. We talk about volume and surface area because both of those deal with 3-dimensional shapes. The volume of this cube is 2 meters. What is the surface area? So it's giving me the volume and I have to find the surface area. Ooh, we got a little bit of a math puzzle here. I like these. Well, what do we need for surface area? Because that's what we're trying to find. And we know that for surface area, the formula of a cube is 6 times the area of one face, of one side. And to find the area of one side, we need length times width. Therefore, what we need to find the surface area is the length and the width. Okay, now that I know what we need, let's look at what we're given. We're given a volume of 2 meters. And I just realized I made a mistake, so give me just a second. I'm going to change this problem up. All right, there we go. I had typo, forgot that 7. So our volume of the cube is actually 27 meters. All right, well, what do we know about the formula for the volume of a cube? Well, that is length times width times height. And if it's a cube, that means all the sides are the same. So I need to figure out what number multiplied 3 times is going to give us 27. Well, if we do 1 times 1 times 1, we're going to get 1. So nope, that doesn't work. If we do 2 times 2 times 2, well, 2 times 2 is 4, 4 times 2 is 8. No, that doesn't work. All right, how about 3? If we do 3 times 3 times 3, well, 3 times 3 is 9, times 3 is 27. Ah, there we go. I solved the mystery. That one works. So in order for a cube to have a volume of 27 meters, it needs to have a side length of 3. So we have a side length of 3. Now that we know that, can we find our surface area? We can, because that's all we needed. We needed to know our side length. We needed to know that length times width. All right. Oop, I should make my color match here. Sorry about that. So surface area is equal to 6 times the area of one face. Well, length times width would be 3 times 3, which is 9. And then 6 times 9 is 54. In this case, it would be meters squared. So if a cube has a volume of 27 meters, its total surface area would be 54. All right, let's get into our final section of this Unit 3 review. Cross sections or slice solids, you may also have heard it referred to. That is when we take a 3-dimensional shape and we slice the solid, and then when it opens up, it gives us a cross section where there is a 2-dimensional shape that we can see as our base. And when you are working with cross sections, you can either do it horizontally, which would be this example, this one, and this one. Those are all examples of a horizontal cross section. Or option number 2 would be you could also do a vertical cross section. So where you split that 3-dimensional shape vertically, which would be our 2 on the left here. All right, here we have a cone and we are slicing that solid and we want to identify what the cross section is. So this blue square here is how we are slicing it. So it's telling us it's slicing it this way, and we need to imagine, okay, if we pulled those pieces, what 2-dimensional shape would we be given? Well, if we open that up, we can see here that it would create a circle. So therefore, this is the correct answer. That is the cross section of a cone. All right, that is it for our review video. If your Unit 3 test is open, make sure that you go forth and you take your Unit 3 test. Work all the problems out. When you get to those volume and surface area questions, have that paper next to you, have that calculator so you can follow your formulas and work it out step by step. Don't try to do it all in your head. You might get your numbers confused or use the wrong formula. So use those formulas, use your notes, use some blank paper to work out the problems, and I know that you can do this. If you have any questions, reach out for help.